Hello, everybody, and welcome to the stream. We are going to talk about event sourcing again. This is the second part of the conversation, and you don't have a conversation alone. You have a conversation with multiple people. So let me bring on my colleague, Brent. Hey, Brent.
Hey, hi, Freek. Hi, everyone.
Hey, how are you doing, Brent?
Yeah, I'm fine. Actually, my wife is almost ready to give birth to our second son. So things are quite exciting as well.
Yeah.
I've got my phone right in front of me. So if I
Okay.
suddenly run away, then that's why.
Then we know why. Then there's
yeah.
another event you need to source.
Yeah. I'm almost as excited as the birth of my second son. There's an event sourcing course coming. I'm really looking forward to that.
Yes.
So yeah.
Let me give a quick intro before we start with the real content. Let me do a little bit of window management and share my screen. So yeah, Brent already mentioned it. He's looking forward to a course. It's a course that mainly Brent is recording, and my whole team is working along with polishing the content. And it's a course on event sourcing in Laravel. You'll find it at eventsourcinglaravel.com. So it's everything that you want to start learning event sourcing in Laravel. The course consists of a book, a demo application, a package, and a video course. And I'd like to say a few words on what the status is of this course, because it isn't released yet. We're currently working on it. So the ebook, it is nearly done. All chapters are written. A technical review has been done by Matthias Novak, a well-known programmer and author in the developer space. And we're now correcting grammatical errors, spelling errors, together with Stephen Moon. He's working with us for that. At Spatie, we're all Dutch speakers, but I think it's a good idea to let a native speaker review an ebook as well. We're also working on a demo application, and this is the application that we're going to show you today. So it's a fully functioning shopping cart. It's a Laravel application that surprises no one, and everything is modeled using event sourcing. So I'm excited to see that in action. A few words on the package. We've actually changed our plan here. So I should adjust this on our site. Our initial plan was to launch a pro version of Laravel event sourcing and make that part of the paid course. But we think it's better for the package and better for getting more people into event sourcing by keeping this package free. So we've decided to not create Laravel Event Sourcing Pro, but we'll release our update as a new major version of Laravel Event Sourcing. There are a couple of new interesting features being introduced. There are some parts that have been rewritten, and this surprises no one. The package will require PHP 8 because we can use all sorts of nice things that were introduced in PHP 8. And the videos, they've all been recorded. We're currently doing some post-processing, making sure that everything sounds and looks fine. So yeah, we're nearly done. My colleague Seb is also working on making a PDF version of the HTML of the book. That's something we'll likely also blog about, on how we process that. And an educated guess for a release date would put this at the end of May, beginning of June, somewhere that I can't give like a promise on the release date just yet, but it's close. We're working on it. Okay, let's go to what we wanted to talk about today, and that is about this demo application. I should also mention that if you have any questions at all, just put them in the chat. I'll keep an eye on that, and we'll pick the most interesting questions, and we'll answering them here live on the stream. Okay. Brent, did I miss anything general here?
No, I don't think so. I already saw someone asking if the course will be centered around a specific app team. And the shopping cart that we're going to show you today will be the example used throughout the course, but it's not that we're only focused on e-commerce or shopping carts, stuff like that. It's really just the example to get you started, to wrap your head around everything that comes with event sourcing.
Okay, Brent, I'm going to share your screen so you can see the application. Here we go.
Okay, great. As you can see, this isn't styled yet, of course. That's one of the last things we still need to get in place. But luckily, we've got the tailwind and my awesome front-end skills, and this is what I came up with. So
yeah, this is also about the front-end skills that I have. I couldn't do it any better, I think.
Thank you, Frick.
So job well done. But I'm also glad that we have Willem to give this a little bit of love.
Yeah, definitely. I'm going to walk you through the basic flow of a shopping cart, but you probably all of you are already aware what will happen. We have a list of products. We can add items to our carts, and we can go to our cart. And I'm going to stop right here because a lot of things already happen. And you already saw me looking at the database over here. This is an event-sourced application, and like we discussed in the previous stream we did together, is that event sourcing is especially useful to model things that happen through time, processes that are time sensitive. And shopping carts, including payments and orders that are made and maybe mail sent here and there. It's a process that is especially models well with event sourcing because the aspect of time flows throughout the whole process. So like Freek said, almost everything in this demo application is event sourced. So let's go to the stored events table. And you can already see a few events were added already. Remember, I added some items. I think these are the last two I added. Already did some testing before. And these are the events. If you've used our event sourcing package before, you know this is probably familiar. We store event classes. We keep a JSON representation of all data on the events, so metadata, and also data regarding the aggregate route where the event was triggered from. And let's do a few more things before actually looking at the event stream again. I removed two items, which made my total cost drop below €100, I think, and you saw shipping costs were added here. I came up with some business rules to show what's possible with our event sourcing package. So, I mean, this probably doesn't make any sense, but go along with the flow. So let's refresh our table over here. We remove two items and we can see another event was actually dispatched. One saying that shipping costs were added again to the cart. And let's add another item again, making our total price more than 100, right? You can see shipping costs were removed here, and the event stream also shows exactly that happens.
Yeah, and that's the kind of event that you don't get in like a traditional system, right?
Yeah.
In a traditional system, you would, when something is deleted, you don't keep that. That is just removed from a table, or and in this way, you know that this happened.
Yeah, this is an especially useful principle if this is the kind of information that you're interested about. And imagine this is a real shopping cart, like an Amazon.com or something like that. You really want to be able to do analysis on user behavior. How do they use your shopping cart? And keeping a very detailed log of everything that happens makes that possible, and it's a really powerful principle, like we also discussed in the previous stream. So let's do another few things here. I removed a coupon, and let's add it again. It's this one, right? Yeah, coupon used. And let's proceed to the checkout. And of course, since this is a example application, we don't integrate with any payment providers. So I have a pay now button here, but let's review the event log once more, because a few things happened here. We checked out a card, which is basically a state change on the card itself. We also locked it, meaning that cards cannot be altered anymore, which is rather important once you've checked out the card. Likewise, an order was created, and with that order also a pending payment. And the payment is actually the thing you would make an integration with some kind of service payment provider with. So as soon as the payment is marked as paid, a few things behind the scenes will happen. The order will be changed status from created to completed, I believe, and the card will be marked as paid as well. So let's just do that right now. Imagine the Pay Now button. It would go to some kind of payment provider to actually make a payment, but it will just happen automatically. Let's review the event log once more. Payment paid, card paid. Oh yeah, order isn't completed yet, and that's because a few things need to happen when an order is, well, the payment for an order is paid. There needs to be some kind of PDF generated as an invoice, and it needs to be sent to the customer, and that's done in Horizon. So let's run it right now, and in just a second. Okay. And the order is completed now. The PDF is available, as you can see, like so. And let's review the events table once more. Here's the order completed event.
Nice. So everything worked as expected.
Yeah.
That's already a good beginning.
And I would think it would be interesting to go through these steps one by one and look at the code to see what happens behind the scenes, because it's one thing to trigger an event, but you also saw some other events automatically triggered because of certain conditions being met, and it's actually a little bit more complicated than just triggering one event every time a user presses a button or something like that.
Yeah.
So maybe before diving into the code, we originally planned to release this as some kind of package with the course that you could just pull in and create your shopping cart with. But we actually stepped away from that idea because event sourcing is especially useful to model more complex program flows. And it would be kind of counterproductive trying to model a flow for a shopping cart as a package to try and make it very extensible or configurable to try and cover all possible scenarios. Well, it's actually impossible. So instead of a package, we decided to just keep this as a project for people to start from. They can change whatever they want. They can throw stuff out. They can build on top of it. And you've got a lot more freedom. And I think that's really the right choice here, because we don't want to think of event sourcing as a generic solution. It's really a tool for you to model your complex business processes the way you want to. So let's go to the code. And most of the interesting stuff will happen in this domain folder over here. You can see there are some aggregates. We already mentioned cart, order, and payment. There's, of course, products as well. Inventory here. I didn't show that in this example, but products could have an inventory attached to them so that you can only buy a given amount of products until the inventory is replenished. customers that I was logged in as a customer, and there are coupons, and I'll also show that. And finally, there are reports, but we'll come back to that later. Let's take a look at the card, first of all. And Frank, I think the most interesting way to dive into an event sourcing application is to actually start looking at the events, because events are the single source of truth. That's a sentence I repeat over and over again in the book. So if you look at the events, you know what's going on in your application. So let's take a look over here. We have checked out, failed, initialized. I didn't show any failed flow yet. We can add items, remove items, log the card, pay the cards. Card can be unlocked again. I also didn't show that. Coupons can be removed and used, and shipping costs can be added and removed as well. We also showed that flow.
This is basically like the equivalent that's looking at a routes file in an application you don't know yet to just get your bearings. What does this do?
Yeah.
And in an event sourced application, you can just take a look at the event so you know what kind of things that can happen.
Yeah, definitely. And it's worth mentioning that not every event can be triggered directly by the user, of course, like the shipping costs added and removed. Maybe you would want to build some kind of admin interface where there could be some kind of override and shipping costs could be removed, even though you don't meet the required amount of items or money in your card. But these two happen behind the scenes, basically. But still, it's something. It's some kind of functionality that can come out of this card aggregate. So besides events, there's also actions, which are really the entry points of for a developer. From the point of view of a controller, for example, you would never want to interact with an aggregate root class directly because there's some overhead to it. And we have actions here, but there's also a command bus implementation which offers a little bit more flexibility, but also requires a little bit more setup. So flexibility comes with a cost, as always. But let's look at the add card action over here.
Maybe could we maybe start by looking at the controller, because this is
that's where I'm going. Yeah.
Okay.
Yeah. I'm going to look at where it is used, and that's the add card item controller. Inputs here is a product and a customer. Let's go back to the products page. I add a card. I'm the logged in customer. You can't see that, but I did log in. And the product is the one that's selected. And the first thing that happens is to check whether the customer has an active card available, because I actually just checked out the previous card. So let's look at our event log again. This is where it starts. Here's the new card initialized event. That means that the previous card is done or failed or whatever, and we start with a new and clean card. First thing that happens after that is that shipping costs are added. And let's just take a look at what happens in the initialize card action over here. First off, we're going to create a new card UID because it's a new card. So we're going to retrieve the aggregate root for that newly created UID. We're going to call initialize. And what happens here is, first of all, a check whether the card actually can be initialized. And secondly, we're going to record an event, and we're going to record immediately a second event, namely that the shipping costs were added. You could also manage this with a reactor if you want some more indirectness, which offers some flexibility, but it's not needed in this case. So two events are triggered, which you can see over here. And immediately after that, return to our controller, we're going to call the add card item action. I'm going to give it a card, the product, and an amount. And in my implementation, it's always one. You can also always only add one product. And because, let's go to the add card item action and look at the aggregate root. That's the aggregate root method. That's add item on it. You can see there's a check here that verifies whether the shipping cost should be removed based on a given amount, a given threshold, right? And that's why we end up with a couple of events. And this, of course, it happened all behind the scenes, because from the point of view of the controller, we just call two actions. First, we initialize the card, and secondly, we added a card item, right?
Yep.
Okay. Let's continue with our flow over here. Using coupons isn't all that difficult. There's a coupon controller over here. It will use another action, and that one will call the use coupon method on the card aggregate root. And notice always how we do state checks in our aggregate root, because the aggregate root's responsibility is to make sure that nothing invalid can happen, right? So let's actually look at this state can use coupon. And over here, it said that coupons can only be used if the card is pending and if no other coupon was used before. And really, this is one of the very important responsibilities of the aggregate root, to say it with DDD vocabulary, to guard against invariance, right? To guard against invalid operations that shouldn't be allowed to happen. But if we are allowed to add coupons, we can record an event, and that event will result in quite a lot of side effects. Well, in this case, there's probably only a few. Let's actually look at what happens here. There's a card projector. And before looking into that, because we have this stream of events, right? But there really isn't, it isn't very handy to work with this raw stream of events, which is why we have interpretations of this event stream. Could be one way of looking at it, could be several ways, and those are called projections. So every time an event is triggered, projections are also updated. So let's look at cards. Cards themselves. So this is the card projection. We could throw this away and replay our projectors, and as long as the events are in our table, all is fine. And you can see that coupon code here, code was used, and a reduction is also stored. If we were to remove the coupon code, you would see it's set to null. Apparently, this is my last card. I was expecting it to be this one, but
and that is the projector updating like the view on the events here. Yeah,
that's right. So let's just continue our checkout. We have a new order here, and what happened now is that, let me look up the checkout method here. So whenever we check out a card, we again do some state checks to verify whether checking out the card is actually allowed. And next we record the card checked out event. Now it's getting interesting, because as you saw, we didn't only change the status of the card itself to checked out, but an order was also created. Right? Order 2, this one. And you can see the state here is, I forgot to use proper names here. That's my bad. It's the pending payment order status. So this order is currently waiting for its payment to be paid. And you didn't see any order events triggered from the card aggregate root. And that's good, because the card aggregate root's responsibility is to handle everything that has to do with the card. But the orders are quite another concept within our domain, and have lots of complicated functionality associated with them as well. So it wouldn't really make sense to try and model the whole flow from beginning to end using the card aggregate. you would really start making a mess, because there would be too much code, and it would really start to become very difficult to maintain. And so that's why there's the order aggregate over here. But we still need to make some kind of bridge between a card being checked out and an order being created. And that's what we use reactors for. You can see there's a card to order reactor here. And reactors, they are just simple event listeners. They won't be replayed like projectors. They're only triggered once. But reactors,
when the original event happens, right? That's when they're triggered and not on replay.
Yeah. So reactors are a great way of moving the program flow forward, and this could mean sending a mail or creating a PDF. But it would also mean if a card is checked out, we're going to create an order, and that's exactly what happens here. So we listened for the card checked out event. We're going to find the card retrieved from the database. First of all, we're going to log the card, and this should actually be moved to a reactor in the card aggregate, probably, because this has nothing to do with orders. But that's a little mistake from my end. More importantly, we're going to create an order. Create order is the same. Again, this is an action. It will call this static constructor on the order aggregate root, but basically it will create a next order number. It will record an event and return itself. So return the instance of the aggregate root. And because all of our projections are run in sync, we can already immediately retrieve the order from the database. If you were to deal with asynchronous event handling, you wouldn't be able to do this, because the order wouldn't exist yet, and you would need to implement some kind of front end polling or something like to be able to update your interface. But
could you show us the projector where the order is being created?
Yeah. So let me take a look at order created event, right? And let's look at the projector here. So on order created, and quite a lot of stuff happens, of course, because some data is copied from the card to the order. And I don't really mind copying over data, because these are projections. You can throw them away, and it's useful to just have the data in one place instead of having to rely on many relations, which could cause performance issues. Keeping data as flat as possible is really my preference in order to prevent having to deal with all kinds of performance issues, basically. So the order itself is created, and we're going to loop over all line data, every line for one product. We're going to create an order line, and that's basically it. So let's look at the order lines table over here. You can see these two are for my order right now, I believe. Oh no, it's this one. Yeah.
Brent, I have an interesting question here in the chat that we could answer. That's relevant, I think. So it's about loading the order or card from the database.
Yeah.
If for the same event, but I don't think event is the right word in the question, the order card is needed in multiple projectors and reactors, say 10, does it mean you'll likely make 10 DB queries?
Yes, maybe. What you usually want to do is rely as much as possible on the data that's in the events, right? And that's what happens over here as well. We have an order created, but it has an order data transfer object, which contains quite a lot of information that would technically also be available in the database. But we really prefer to have it in memory on the fly, especially because we don't want to deal with those kind of performance issues. And there's even the order line data, which is again a DTO. This is one way of looking at the problem, but of course there are times where you want to query the database directly. You don't want to deal with having to keep several DTOs in sync, or they're becoming too large, and that's fine as well. Remember that this happens on the right side, so the right side, not the right side. Okay. Whenever a projection is written, you could send it off to a queue if you want to, if it really starts to become too slow, but you will have to deal with that eventual consistency, that the projection doesn't exist the moment your request finishes, and you need to take that into account. But on the other hand, while the writing data takes a little bit longer and might perform 10 database queries, reading data becomes very, very performant because all data is already in place. And that's kind of the thing you have to keep in mind, that with some complexity also comes a lot of flexibility. And that's just the balancing game that is event sourcing. It definitely isn't the right solution for all problems, but in cases where the process is rather complex, it might actually save quite a lot of time in the end.
Yeah, I'm thinking that in event sourcing in general, that reading stuff becomes a little bit, how should I say it? Yeah, when you want to write stuff, it's indeed a little bit more complex, because you have multiple things firing. Mm-hmm. But if you want to read stuff, you can, if you're taking a look at the projector side of things, it can really speed up some things, because you can basically create a projection that your view expects. So you could basically create like a projection that contains everything that the card view needs. So it's only one query. You could do that.
Frank, to take it one step further, you could make a projection that's just a rendered HTML file if you want to.
Yeah, indeed, and just display that. But reading can also, if you're taking it, if you're looking at it from the aggregate root side, it can seemingly become a little bit more expensive, because you need, for your aggregate to load, you're going to reconstitute your aggregate from all past events. So you need to read all past events. But like we said in the first stream, this is where databases are pretty good at it. Just give me like the 10 rows or the 20 rows for this key. It will happen so fast, and that's a little drawback. But in most practical cases, you're not going to notice that it's slow. Mm-hmm. And even if it becomes slow, if you have like thousands of tens of thousands of events that you need to retrieve, there are solutions for that, snapshots. That's also mentioned in the book.
Yeah. So it's always the balancing game. Also, I mentioned it a few times in the book as well. It's just it's a matter of weighing complexity against flexibility. So
we got an okay from Richard. So I think
Richard,
it's okay to continue. The question has been answered.
All right, awesome. Let's just briefly continue with the flow. We still have the pay button over here, and Horizon is still running. Let's trigger it. And let's go to the PDF. Yeah, okay, that's good. It's still being generated. So there's some kind of waiting screen. This is what I mean with eventual consistency. The pay button was really fast, and a few of the events were pushed to the Horizon queue, and we'll have to deal with that in the user interface. But it also makes that our user interactions are being kept very fast and responsive. And now the PDF is ready. You might want to mail this to the user when it's done. And let's take a look how all of that is done. And I actually think it's in the order completed reactor. No, the order paid maybe. Yeah. Here's the. So when a payment is paid, two things will happen. First, we're going to create the invoice PDF for this order. That's like really a snapshot of this is paid and it's never going to be changed. At least in Europe, that's not allowed. And you can see here, this reactor is queued. So this happens asynchronously. And once the invoice is created and we have a path to the generated file, we can actually complete the order. By the way, invoice created, it's just creating a file and using BrowserShot to create a PDF. But once it's created, we call the complete order action and we give it the path to the invoice, which means the invoice PDF itself isn't stored as an event. That would be rather bad for database performance. But we store the invoice path and the file exists on disk. And we know we can never change this unless we want to we regenerate PDF or something, but that's not allowed. So it's a very easy example in that manner. And when the complete method is called here, you can see it's just another event that has some projectors listening to it, and the cycle continues.
Cool.
Yeah. I'm thinking what else is interesting to show.
Maybe there's like another projection in there, right? I think card duration. Maybe you can say a couple of things about that.
I mentioned this before. A projection is just one interpretation of the event stream. It's like a window looking into the event stream, and you can make whatever you want with projections. You could store HTML files. Usually, most of the time, those are database records. But what we did here was we have a card projector, which handles the card projection that's shown to the user, that makes sure this screen can be shown, right? But meanwhile, we also have a card duration projector. And that's... Oh, okay. Okay, doesn't work. Never mind. It listens for the same events. Card initialized, it listens for card checked out. And actually, that's all, because what we want to calculate here is how long users spend from card initialized to actually checking out their card. Imagine that's a business question that some managers want to know, or that some marketing engineer wants to know to be able maybe to optimize the card flow, stuff like that. So whenever a card is initialized, we will create a new card duration projection, which only keeps track of the card UID and created at. And we can reuse the card UID as the UID itself, because there will only ever be one duration projection for a card. And whenever a card is checked out, we will write the checked out date to the database as well, but we will also calculate the duration in minutes. And so this projector listens to the exactly the same events or part of all the available events. But it gives us a completely different view of that event stream. And another benefit is that if our managers asked us to create this report 2 years after the project had gone to production, well, all events are still stored. So we can replay this projector with all previously stored events, and we can get that data for all cards in the past. And that's really one of the powerful advantages of event sourcing. And to show you the end result, card duration. Okay. So duration in minutes, you can see it over here. Yeah, this was the card that I already created when we started our session, so that's a little longer. And the other one apparently took 5 minutes to check out. Started at yes, there's some time zone issues here, but that's okay. Started at 3 past 1 and ended at 9.
And you can, I think, come up with all sorts of nice use cases for this. Reports that you don't know beforehand that you're gonna need, like in how many in how can I say this? Like what is like the average duration of a cart checkout? Which products were removed the most? We did a promo on product X. How did that affect product Y? Did it get removed more? Stuff like that.
Yeah, it's very powerful. And then we don't only come up with these kinds of use cases, but your client and management people, they will, and they ask all kinds of strange questions. And I can honestly say, I in the past year or so, I've been working on an older project where we didn't use event sourcing, and almost every week there was 1 or 2 instances where I thought, oh, event sourcing would have made my life so much easier and would have made this feature so much easier to implement. But that's part of legacy we have to deal with still. So it's really powerful.
Yeah, if you have like the right use case, then it's really good. Something that I always keep in mind, I've probably also said it in the first part of the conversation, something that Frank de Jonge has said, like event sourcing makes easy parts difficult and difficult parts easy. So for a blog, it isn't probably needed and it's overhead, but if you need to make decisions based on the past, that's kind of hard sometimes. That are things that event sourcing can make easy.
Yeah, I was looking at replaying for a moment, but I was thinking I also had some kind of replay commands. Okay, so let's just give it a try, right? I haven't tested this, but I removed all my card durations, and I'm actually not sure what's let's close this one. We need to give the projector class, right, Freek? Is that right?
Yes.
So it's probably something like this. Okay.
Yeah. That yes. Fast, and there it's back. Nice.
Oh, that's nice. Yeah. Yeah. So just to show that the with the event stream and only the event stream, you can rebuild your whole application state, which is quite nice.
Yeah, indeed. Good, Brent. I think that we've now shown like the things that we want to see, right?
I think so. Well, there's more to tell, but people will have to take a look at the course.
Yeah, indeed. So this application, it will be fully fledged. Example for event sourcing will also include tests for this, so you know how this works. Yeah, like Brent already said, we started out with this as like a package. It's like a card package that you can build in an existing application, but having it as a separate project is much better, I think, because you can mold it into whatever you want. And I think that this is like a perfect example of how you can use event sourcing in a real world application. In the documentation of event sourcing of the package, there were like examples for Laravel, but you're probably not going to work at like the core functionality of a bank. Probably you won't need to do that, but this is like a real life scenario. Like if you're doing something in e-commerce, then a card is something you need, and then this is like a very nice example, I think.
Yeah, this was actually inspired by one of our projects, right?
Yeah.
One more
Okay.
thing I wanted to show, Freek, was
Yes.
the timeline over here. A way to
Right.
model event-sourced systems is to use a technique called event storming, and this is one way of doing it. And because of COVID restrictions, we have to do this digitally. But normally, you would go into a room with the client with sticky notes with all kinds of different colors and start hanging them on the wall. But this gives you an overview of the events that can happen. Those are the orange cards, and how those events can happen, and how those events can result in new events happening. Like over here, we have card checked out. I show that. There's the cards to order reactor that will result in a card locked event, an order created event, which in turn will create a payment for the order. I didn't show that, but you can imagine what happens over there, and so on. So even though it's this is still a very small application, there's still a lot of things going on behind the scenes, and you can build on top of this.
Yeah, and the cool thing about this is I think there's nothing technical in those notes. Clients can help discover with this because you can ask a client, hey, okay, so you want the card, what should happen?
Yeah.
And then your client can think like, okay, what can happen there? And you can discover things together without technique getting in the way. That's what I like very much about this.
Yeah, it's actually meant to be done with the client. And in this case, I was the client myself, but this kind of exploring the problem space is really valuable when you do it with the client, because they have the business knowledge and you don't. So it's really great to get on the same page and discover things about what needs to be programmed.
Cool. Yeah, I can't wait for the course to be released, Brent. I've already seen it, but I think, for a lot of people, even if they're not primarily interested in event sourcing, it can be worthwhile because, these kind of techniques, they can fit everywhere. I think we said that also in the last stream, that you don't need to go full on event sourcing. You can just use small principles of this here and there as well.
Yeah.
Okay, I'm going to start winding it down. I'm going to unshare your screen, and I'm going to maybe to end it, put the site once more on the screen. So if you liked this stream, check out our upcoming course, eventsourcinglaravel.com, or if you're watching a recording, maybe if you're lucky, the course has already been released. I think this is like the best resource to get started with event sourcing in Laravel. And we're pretty proud of it. I hope that everybody liked the stream. I certainly liked doing another one with you, Brent, here. So
yeah, definitely. There's one question. Richard asks if the course includes event storming, and yes, there we use event storming throughout the book to really get the big picture of the system we're building, and where we explore it step by step. And there's also a chapter dedicated to some of the principles of event storming, because there are quite a few variations of it. And the book uses two variations. I explained two variations, but there is some content spent on the topic.
Cool. I think we also have like more questions in our Drive document, like questions that were asked on Twitter. Maybe it depends a little bit on your situation. Brent will do another stream next week, maybe, where we'll answer those questions. Maybe not.
Yeah,
we'll see.
Yeah, it will depend on whether the baby comes. But I'm looking forward to that. And if it's not next week, then it will be in a few weeks. But definitely want to do that.
Cool. I think we're finished here then. Thanks, Brent, for explaining that to everybody here.
You're welcome.
And thanks everybody for watching. Bye-bye.